In today's lecture, we are going to learn some more new ideas and concepts of differential equations chapter. In the last lecture, we have understood what is differential equation and what is the solution of differential equation, how do we represent it on geometry, all basics we have learned, and also we have learned one method of solving differential equation using variable-separables method. Okay. So, we could not solve much questions in the last lecture. So, today we will start with the questions where we have left off, and after that we will learn new concept, that is linear differential equations, and then also we will learn some problem solving skills on that. Okay. Shall we start now? So, there was this question, of course, I maintained the same number as the last lecture. So, initial out of the 4 questions I had solved 1 question and others I have given as homework. Those were easy questions, so I am just skipping them, but now I am solving this because this involves little bit of idea. So, I will just explain the idea and I will also solve the problem. So, what is the idea here? Idea is to substitute x plus y equal to any new variable, let us say it is z. Okay. So, here it becomes y dash equal to cos of z minus sin of z. Basically, I have substituted x plus y equal to z. So, if I use x plus y equal to z, then I have to convert y dash also in terms of z dash. So, suppose let us say I differentiate this both sides with respect to x. What do I get? I get 1 plus y dash equal to z dash. So, that means we can say that y dash is equal to z dash minus 1. So, here I can put z dash minus 1 equal to cos z minus sin z. Okay. Now, further we take 1 to the other side. So, it becomes dz by dx, basically that is our z dash, is equal to 1 plus cos z minus sin z. Now, can we now separate the variables? Of course, we can. So, we can write this as dz by 1 plus cos z minus sin z is equal to dx. Now, we want to integrate, but before integrating, just observe the terms. RHS is a very simple term, integrating RHS is going to be very easy, but LHS is little bit complicated. So, how do we integrate this? We can also go for the standard substitution of cos theta equal to 1 minus t square by 1 plus t square, sin theta equal to 2t by 1 plus t square, but that idea is going to take lot of time. So, instead of that we can also directly simplify this using trigonometry, but at the end both ideas will merge into the same method. Okay. So, 1 plus cos z here can be written as 2 cos square z by 2 and sin z can be written as 2 sin z by 2 cos z by 2. Now, if I divide this entire denominator with 1 plus cos z, that means I am taking 1 plus cos z common. What do I get here? So, if I divide these two, I am going to get tan z by 2. So, here we can write this as dz divided by 1 minus tan z by 2. Basically, I have divided sin z with this term, but this term is actually taken common, but this term is same as 2 cos square z by 2. So, we can write this as 1 by 2 into, in the denominator we have cos square z by 2. So, it becomes sec square z by 2. Okay. And the RHS is still dx. Now, we will integrate this using our standard ideas. So, we can write this as integral of half sec square z by 2 divided by 1 minus tan z by 2 into dz is equal to integral of dx. Now, if I take 1 minus tan z by 2 as let us say t, then my dt will become minus sec square z by 2 into 1 by 2 into dz. Basically, I have applied the chain rule. Now, further in place of this numerator I can directly substitute minus dt. So, it becomes minus dt divided by t, that is equal to integral of dx. Now this is a simple integral. So what will be the integral of this? It's going to be minus ln of mod t, and in RHS we will get x plus c. Okay. So if I write directly t, so we can say mod t is equal to e power minus x minus c, or we can also write it as constant k into e power minus x. Now what is our t? T is basically 1 minus tan z by 2. So mod of 1 minus tan of, what is z? Z is nothing but x plus y. So x plus y by 2 is equal to k into e raised to minus x. Okay, so this is the solution of the differential equation. So here you can further write y in terms of x, or you can just leave it right here. It does not matter. Okay. So this way we can solve this problem. While solving the problem, what are the ideas that we came across? One idea is substituting x plus y equal to z, and other is to handle this trigonometric integral. Okay. So that is why I have discussed this problem here, because I just got the idea that maybe you may get stuck somewhere, so I just helped you out. Okay. Come on, make a note of this. This page also. Okay. So now we will move on to the next question. This question we have solved in the last lecture. Let us solve the next question. So here the question is, find the nature of the curve, of course which is not passing through the origin, for which the length of the normal at a point is equal to the radius vector at that point. So for this problem I have just discussed the idea in the last lecture, but I did not solve, but now I am solving this. So how do we proceed? We have to assume one curve. Let's say this is my curve, which is y equal to f of x. Now at a point P, let's say P is somewhere here. At a point P, there is a normal. This normal is going to intersect x-axis at some point. So let's say this is my x-axis. So this is going to intersect at a point. If I name this as point as n, this Pn will become the length of the normal. Okay. So Pn is our length of the normal, and if we take the origin as let's say O is somewhere here. So from O to P, if I join, that becomes our radius vector. In general, what is the radius vector? Radius vector is the vector joining the variable point on the curve to the origin. So radius vector ideally should start from the origin and go till the point, but when we say length of the normal is equal to the radius vector, it means we are talking about the scalar terms only. Okay. So basically we have to use this idea that Pn must be equal to OP. So that means I can also square this to get rid of the square roots that may get involved. Okay. So now to get the length of the normal, I can directly use the formula of the length of the normal, but I am going with the idea that you may not remember the formula. So that is why I keep stressing that you learn the methods, do not remember the formula. So I will go with the method only, I will not write the formula directly. Okay. So our first step is going to be assuming this point to be h comma k. That is our first step. After that, the slope of the tangent will become the derivative at that point. So slope of the tangent is basically f dash of h. Let's say I name this as k dash. So that means slope of normal will be minus 1 by k dash. So equation of normal is going to be, this is equation of normal, it is going to be y minus k by x minus h equal to minus 1 by k dash. Now we want to find the point n. N is the point where normal cuts x-axis. So we will put y equal to 0 and get x here. So if I put y equal to 0, I am going to get x equal to h plus k dash. So that means Pn square is going to be h plus k dash minus minus h whole square plus 0 minus k whole square. this becomes our Pn square. So here h may get cancelled, so we may write this as k square into k dash square plus k square. This is our Pn square. Now what about OP? OP is basically the radius vector, so we can directly write this as the sum of squares of both x and y coordinates. Now these two must be equal, which means k square into k dash square plus k square is equal to h square plus k square. K square will get cancelled. And we got one equation in terms of h, k and k dash. So we have applied all given conditions of the question and we arrived at a differential equation in terms of h and k. Now you go for the substitution of h as x, k as y, and then solve it usually just like the way we solve a differential equation. So when I replace k with y and h with x, we are going to get y square into y dash square is equal to x square. Now looking at this equation, what is the order of this differential equation? It is 1. What is the degree? Degree is 2. But we don't know how to handle the differential equations of higher degree. We only know how to handle differential equations of degree 1, that is the first order, first degree equations. So to apply variable separable method, we need to get only y dash, not y dash square. So we solve for y dash here by applying a square equal to b square idea. If a square is equal to b square, a equal to b is one possibility, a equal to minus b is another possibility. So from here two possibilities come out. Okay, there are two possibilities. One possibility is y dash is equal to x. Other possibility is y dash equal to minus x. Now we will solve both of them separately and see what happens. So here we can write this as y into dy by dx equal to x. Can we separate the variables? Of course we can. So we are getting y dy equal to x dx. Now when we integrate this both sides, we are going to get y square by 2 equal to x square by 2 plus some constant. So this means we are basically getting a curve like this, y square minus x square equal to some constant k. So here k will come out to be 2c, okay. But k is an arbitrary constant, so it does not matter. You write 2c or k, it does not matter. What is this equation representing? It is representing rectangular hyperbola. Is this one rectangular hyperbola or many rectangular hyperbolas? It is actually family of rectangular hyperbolas where center is the origin and y equal to x line, y equal to minus x line are the asymptotes. Okay. Now let us look at the other possibility. Here also it is the same analysis, but only thing is sign is different. Okay. So now we can write this as y into dy by dx equal to minus x. Of course it is the same analysis. We don't even have to write these steps. Okay. So now when we integrate, we get y square by 2 equal to minus x square by 2 plus some constant. Now this means we are getting x square plus y square equal to constant k. This is representing circle. Is this a single circle? No, of course not. It is many circles. It's a family of circles. So what is the nature of the curves? Family of circles or family of rectangular hyperbolas. But both these curves will satisfy this relation. Okay. In fact, in circles you know that length of the normal is equal to the radius only. Okay. So this way we can solve the problem. So in this problem, what is the take home knowledge? One point is we have to assume the variable point on the curve to be always h comma k. If you assume the point to be x comma y, it is going to confuse you a lot. So take the point as h comma k initially, put all conditions given in the question, arrive at an equation in terms of h, k and k dash. After that you can go into the differential equations. Now in differential equations you are going to face this kind of situation in future also while solving problems. So if we get any equation like this where derivative is having a square, then you have to solve for y dash. even if you get multiple possibilities, you have to solve for y dash and handle all multiple possibilities separately. Okay. So, there are 2 points that you can note down in this question, which are these two. Okay. Come on, make a note of the problem. Okay. So, now let us go to another question. Find the curve for which the segment of the tangent contained between the coordinate axis is bisected by the point itself. So, if you use this statement, we will definitely get one family of curves, but when we put this point, because it is given that curve must pass through the point, then we may get one particular solution. So, let us first focus on the general solution. So, for that we need to generate a differential equation first. So, let us apply, let us assume a curve first. Let us say there is one curve here. So, I have taken one random curve, we can take this as y equal to f of x, and let us take one variable point here, which is h comma k, and there is one tangent here at this point, there is x axis and y axis. If I take this point as P, this point as A and this point as B, origin as O, okay, then P is supposed to bisect the tangent contained between the coordinate axis. So, that means this length must be equal to this length, P must be the midpoint. So, what is our approach here? Every time we have to first read the question and we have to design an approach. This is our planning of the solution. So, what is our plan here? First step is to generate the equation of the tangent, find the x and y intercepts, and put the idea that midpoint of A and B must be P. Now, when we put this idea, we may arrive at a differential equation, and then we will see how to solve that depending on the pattern of the equation. So, how do we do that? Let us get the tangent first. Because the derivative of the curve at this point is taken as k dash, equation of the tangent will become y minus k by x minus h equal to k dash. This is the tangent. Now, if I put x equal to 0, I get y equal to k minus h k dash. If I put y equal to 0, I will get x equal to h minus k by k dash. Okay. So, we got basically both points A and B. So, this is corresponding to the point B, this is corresponding to point A. So, we can also write the coordinates here. Point A is going to be h minus k by k dash comma 0, and point B is going to be 0 comma k minus h k dash. Okay. Now, midpoint of these two must be equal to the h comma k point. So, what is the midpoint here? When we find the midpoint, we will get h minus k by k dash divided by 2 comma k minus h k dash divided by 2. This must be equal to h comma k. Now, let us equate the x coordinate and y coordinate separately. So, what do we get? When I equate x coordinate, I am getting h minus k by k dash by 2 is equal to h. So, I can just take this 2 to the other side and give it to h. So, it becomes 2h. Now, if I simplify this, I get minus h equal to k by k dash, or k dash equal to minus k by h. This is what we got in the first case. Now, let us equate the y coordinates also. So, k minus h k dash must be equal to 2k. Now, again when I solve for k dash, what do I get? K dash equal to k minus 2k divided by h, which is same as minus k by h. So, accidentally both equations came out to be same equation. But there could be also possibility that when we equate x coordinate and y coordinate, two different differential equations may come, but in this particular case both came out to be same equation. If both are different equations, you may have to solve both of them independently, and at the end after getting solutions, you may have to look for those solutions which are common to both. Okay? But here luckily both are same, so we will solve only one differential equation. Now we got one relation here. After that, what are the steps? Replace h with x, k with y, and k dash with y dash. Okay? So we will write our differential equation as, this is our differential equation, y dash equal to minus y by x, right? Okay. So now apply the variable-separable method, because y dash can be written as dy by dx, and luckily here x and y terms can be separated using product. So we can write dy by y is equal to minus dx by x. Okay. So what do we get here? Log y is equal to minus log x plus c. Instead of taking c here, we will take this as log of k. Okay. So now if I take this ln x to LHS, I will get ln x plus ln y is equal to ln k. So you know how to add two logarithms. It becomes log of xy is equal to ln k, which means xy is equal to k. Okay. So we got the equation. What is this equation representing? Family of rectangular hyperbolas where center is the origin and x axis and y axis are the asymptotes. Now if you want the particular solution, you may have to put the point in this. So a point 2, 3 is given. So if I put the point here, we will get 2 into 3 is k, that means k must be equal to 6. So xy equal to 6 is our final solution, which is one curve only. Okay. Basically it is one hyperbola having two branches. Okay. So this way we can solve the problem. Now there could be one doubt in your mind. What is it? Is there any mistake that I have done here? I did not put mod when I integrated 1 by x. Generally, what is the integral of 1 by x? Log of mod x. But I did not put mod here. So in differential equations chapter, even if we do not put mod, it is not going to affect our solution. Now let us say your doubt is still there. Let me do it with the mod and see and explain if it is different, if it is giving any different answer or not. Okay. So after this step, when we integrated this both sides, our LHS would be ln of mod y, RHS would be minus ln of mod x, and here ln of k, right. Now k could be positive, we will see what it is. When I take this to the LHS, I will get ln mod x plus ln mod y is equal to ln k. Now further we can club both of them and write mod of xy is equal to ln k. Now that means mod of xy must be equal to k. So this will lead to two possibilities. One possibility is xy equal to k, other possibility is xy equal to minus k. Now out of these two, which is true? That will depend on whether point is taken or not. So if I put the point 2, 3 here, I will get k to be equal to 6. So xy equal to 6 is one solution. If I do the other case, so here I will get k to be equal to minus 6. So xy equal to minus 6 is other solution. Now check if out of these two which is correct. Xy equal to 6 is basically rectangular hyperbola lying in the first quadrant and the third quadrant, right. Xy equal to 6 possibility, xy equal to minus 6 possibility. So this is going to lie in the first and third quadrants. and here it is going to lie in the second and fourth quadrants. Now where is our 2, 3 point? 2, 3 point is actually in the first quadrant. So that means if I put 2, 3 in this equation, it should not satisfy. So that means this part is actually the wrong solution, this is the right solution. Okay. So this way you can take care of it if you go for the modulus, but even if you do not put the modulus, it is naturally taken care, especially in this chapter. Okay. So in most of the questions we proceed without putting modulus only. Okay. Come on, make a note of this. This page also. Okay. So here, as I discussed in differential equations chapter, you don't have to worry much about the modulus, because when we put the point and when we simplify it, it is naturally taken care. Okay. But if you put modulus and solve it, then it may actually cause even more troubles. So that is why do not go for the mod directly. Okay. If you are going for the mod, you need to verify also. Okay. Okay. Next. Now we have finished all examples on variable-separable method, and let's go to the new idea, new concept, which is LDE. What is LDE? In the last lecture I have discussed, LDE is basically linear differential equation. Linear means it should look like a linear equation. We have learned lot of linear equations since our school days also. So in general, ax plus by plus c is a linear equation. So there x and y, those variables are actually having the degree 1. So here also some terms will be having degree 1. What are those terms? Those terms must be y and the derivatives of y. Even if x has degree 20, it does not matter. What matters are the degrees of y, y dash, y double dash, and so on. Okay. So it is basically a linear equation in terms of the dependent variable and its derivatives. So that means y and their derivatives. Now here, if you are taking x as independent variable, y as the dependent variable, then linear equation could be in terms of y, y dash, y double dash. If you take the other way around, y as the input and x as the output, then dx by dy, d square x by dy square, x, these terms must be in the linear form. Okay. So I have put one example of that kind also, we will see in the problem solving. So here in this example, if you notice, there is y double dash term, there is y dash term, y term, and there is another term. Here a of x, b of x, c of x, d of x, these could be functions of x. They may have any degree or transcendental, or it does not matter. What matters are the only degrees of these terms. Because all these three terms are having the degree 1, it is a linear equation of differential equation. Okay. So we can say that this is second ordered linear equation in differentials. So any linear equation could be of any order, but in our standard 12th standard in JEE syllabus also, we have only linear equations of first order. Linear equations of second order can be solved in your engineering time. Okay. So I have also solved lot of questions in my second and third year of engineering, especially in physics also. Okay. For example, if you are, let's say, studying the shock absorbers of your car, you are going to be basically handling an equation of this kind. Okay. Even if you are taking simple harmonic motion or spring mass system, even in those cases also, generally we neglect friction and damping, but we will take friction and damping and solve the questions in future when we take the damping, or this first term will be there. So that way you will be anyways experiencing that. So let us look at what is there in our syllabus. It is going to be some kind of this term, but this is not the standard standard linear differential equation. It is not the standard. We divide this equation with b of x and write the standard form, which is basically this form. Okay. So our standard first order linear differential equation must be of this type only. Otherwise, our methods will not work. So, even if the equation is not in the standard form, we will convert that into standard form. For example, let us say we have one differential equation here, sin x into y dash plus cos x into y equal to, let us say, sin cube x. Now, I have to divide this with sin x to get this in the standard form. Okay, so this is the standard form of the first order linear differential equation. So now what we have understood, what is linear differential equation, what is the general linear differential equation, what is in our syllabus, what is the standard form. Now let us look into how to solve this differential equation. Okay. So let us look at the solution process. So here there are actually two steps. Step 1 is to go for the integrating factor. Step 2 is to go for the integral. Now integrating factor is nothing but the function that is actually multiplying the y term. Okay. The function which is actually multiplying the y term, that should be taken in the power of e and integrated. So e power integral of f of x dx is our integrating factor. Now why is this the integrating factor? We will see that. But integrating factor means just like the way it is in the name. In mathematics, most of the theory is in the name itself. Here, integrating factor, that means to integrate we have to multiply the equation with this factor. So that means whatever that we get here, we multiply the entire equation with that factor. So now if you notice, this is our integrating factor. Okay, so we have multiplied the entire equation with the integrating factor. Now if I multiply with this, what happens? What happens is LHS will turn out to be one exact differential, or in other words, LHS will come out to be one perfect derivative. So how do we do that? Just imagine that we are taking product of these two functions. Okay. So how do we differentiate product of functions? We keep one function constant, differentiate the other term. So we kept this as the constant, differentiated y, and in the next step we kept the y as constant and differentiated this term. So when we differentiate e raised to integral of f of x, what is the derivative of e power x? It is e power x only. So the same term will come, but derivative of the power will come. So derivative of integral of f of x is same as the f of x. So basically here we have applied the chain rule. Okay. So that means basically LHS will come out to be one perfect derivative. So that means this is the perfect derivative equal to the RHS into integrating factor. Now if I integrate this both sides, LHS will become basically product of integrating factor and y, and RHS will contain two terms. One is the g of x, other is the e power f of x integral. So basically we have one simple idea of the entire method. So here I have explained you the theory. I have tried to reason out every step that I have been writing here. But you don't have to remember all of it to solve a question. To solve a question, remember these two ideas. Okay, so idea is this. First, step 1. Okay, so I'll just take it to the next page. Right here, step 1 is get the integrating factor. IF means integrating factor. Step 2 is integrate. Okay. Now while integrating, what happens is LHS becomes exact derivative. So IF into y is equal to integral of IF into RHS dx. That's it. This is the idea that you have to remember. So step 1 is getting the IF, that means integrating factor. Step 2 is integrating it. While integrating factor into y will come in the LHS. and in the RHS, integrating factor into RHS must be integrated. That's it. Okay. Now let us solve this question and let us see what exactly is this method. Now it is named as illustration, it is not part of problem solving. It is named as illustration because it is going to explain you the theory. Okay. So let us look at this problem and understand what exactly happened here in this entire very lengthy algebra. So we convert this into standard form like this. Of course, it is already in the standard form, but I just separated the terms. So the function which is with y must be integrated to get the integrating factor. So let me get the integrating factor here. It is e raised to integral of 1 by x dx. Now integral of 1 by x is log x. So we will write this as e power log x, but e power log x is nothing but x only. So that means I have to multiply this equation with x and simplify, but we do not need to do so much, we just have to follow this idea. So that means x into y, x is the integrating factor, x into y is equal to integrating factor into what is RHS ln x dx. We just have to integrate this. Now you know how to integrate these terms. What is the integral of this? It is going to be x square by 2 into ln x minus integral of x square by 2 into 1 by x into dx. I have applied integration by parts. I integrated x and differentiated ln x. Now further when I simplify this, I am going to get x square by 2 into ln x minus x square by 4 plus some integrating constant. So y will come out to be x by 2 ln x minus x by 4 plus c by x. Okay. So this way we can complete the solution process. So here you only have to remember two steps. One is the integrating factor, other is this integration step. But now I will explain what exactly went behind the theory. So when I multiplied this with x, what actually happened was this: x into y dash plus y is equal to x into ln x. Now when I observe the LHS, LHS is basically a perfect derivative. Perfect derivative means if I differentiate x into y dash, what am I going to get? X into y dash plus d by dx of x is 1 into y. That is exactly the term that we got in the LHS. Okay. And this is going to be working for all first order linear differential equations. That is exactly the foundation step of the method. Integrating factor is going to make sure that LHS becomes exact derivative. Okay. So this is the whole idea and purpose of the method. I hope you have understood the method. Okay. Come on, make a note of this page also. Now let us look at a special case. Here it is not exactly linear differential equation, because there is one term where y has the degree n is definitely greater than 1. Okay. So n must be a natural number and n must be greater than 1. Okay. So definitely it is not linear equation, but it can be converted into linear equation. And this particular special equation is called as the Bernoulli's equation. So you know the Bernoulli, not the physics Bernoulli, it is actually a complete family of Bernoullis. Everybody had the same surname of Bernoulli, and most of that family, that particular family, were actually mathematicians and physics scientists. Okay. So this is our equation which could be converted into the linear equation. Okay. Now how to proceed with this? What is the crucial crack step to convert this into linear differential equation? This is the crack step. We always call it as the crack. Okay. Crack means it is the key. If you have downloaded any soft games or anything on your computer or something, you must be using cheat codes. So we can call them as crack. Okay. So here this crack is the main step here. So what we are going to do is, what is the term which is actually making this different from the earlier equation? This is the term. In the earlier equation we did not have this term, but now this is the only term which is different. So we will try to get rid of that term by dividing with y raised to n. So in the method also it is the same. We divide with y raised to n, and then whatever term that I get here must be taken as a new variable z. So here when we divide this entire equation with y raised to n, what are we going to get? This y raised to n will get cancelled, and here we will be getting this term 1 by y raised to n minus 1. We take that as z and we try to solve the problem. That is the whole purpose of the method. So what do we basically get here? Y dash by y raised to n, this is one term, f of x into 1 by y raised to n minus 1, this is one term, equal to g of x. Now if I take this entire term as the new variable z, and if I could convert this into z dash, so I will be getting z dash plus some function into z equal to another function. So this will become our standard linear differential equation. Okay. So this is the method. Let us look at one illustration to understand the method. Okay. See, if you by heart the theory, it is not going to help you. You have to solve at least one or two problems to understand the theory. Let us understand theory through this problem. So here the question, the question of course is in Bernoulli's form. So we will write this as y dash plus x into y is equal to x into y raised to 4. So what is the trouble? Trouble is y raised to 4. So we will divide this with y raised to 4. Okay. So if I divide this with y raised to 4, what do I get? This RHS is anyways cancelled. Now what is left in LHS? It is y dash by y raised to 4 plus x into 1 by y cube equal to x. Now I will put 1 by y cube as my z. So if I take 1 by y cube as z, then z dash will become minus 3 by y raised to 4 into y dash. You know how to differentiate. So after we get this, can we directly write this y dash by y raised to 4 in terms of z? See, if you notice here, y dash by y raised to 4 can be written as minus z dash by 3, right? So we can write this equation as minus z dash by 3 plus x into z equal to x. Now this is in the standard form of the first order linear differential equation, but we have to multiply with minus 3 to convert this into that form. So when we multiply with minus 3, we are going to get z dash minus 3x into z equal to minus 3 into x. So we got one form here. What is our next step? Go for the integrating factor. What is the integrating factor here? It is going to be e raised to integral of what is the function which is multiplying z? It is the minus 3x. So minus 3x into dx. So what do we get here? E raised to minus 3x square by 2. This becomes our integrating factor. What is the next step? Next step is direct, that is integrating factor into what is our dependent variable here? It is z, into z is equal to integral of integrating factor into RHS. So integrating factor is e power minus 3x square by 2 into what is RHS? Minus 3x into dx. That is it. Okay. Now further we have to solve this using our regular ideas. So let us solve it in the next page. So LHS is e raised to minus 3x square by 2 into z equal to RHS is e raised to minus 3x square by 2 into minus 3x into dx. Now in general, e raised to x square dx or e raised to minus x square dx, these two functions are non-integrable functions using indefinite style. If you want to use indefinite integration on these two, these are not integrable. You will not get the integral. But using definite integration, you can find the integrals if the limits are known. So how do we find the integral of the non-integrable functions using integration? How do we find? We find them by using limit of a sum. This we have learned in the integration chapter. You can watch my lectures also. Okay. So, but here whenever we get terms like this e power x square, there must be some linear terms which are accompanied. Okay. So, those linear terms are going to help us in integrating such functions. So, here because there is linear term, RHS is integrable. So, how do we integrate? By using a substitution like this. I am taking the entire power of e and I am taking this as t. Okay. So, if I differentiate this, I will get dt is equal to minus 3 by 2 into 2x into dx, which is coming out to be minus 3x into dx. Luckily, this entire term has become dt and this term has become e power t. So, it is integral of e power t into dt. See, that is the beauty of this linear term. So, now remember this idea. If at any situation in future, if you get e power x square in any integral, okay, so you know that it is not directly integrable. So, whatever is the polynomial that you get here, it must have odd powers. Okay. If it does not have odd powers, it will not be integrable. Okay. So, now coming to this, because there is odd power here, it got converted into standard form. So, what is the integral of this? E power t plus c. Now, what is in the LHS? E power t into z is in the LHS. So, z will become 1 plus c into e power minus t. Now, when we put it, we get 1 plus c into e power, t is basically minus 3x square by 2. So, it becomes plus 3x square by 2. But what is z? Z was basically 1 by y cube. So, that means y will come out to be 1 divided by 1 plus c into e raised to 3x square by 2 whole raised to 1 by 3. This is our function. So, of course, in most of the cases where they are not originally LDE, but when we convert them into LDE, the function is going to be somewhat this complicated. Okay, it is naturally like that. But these are some special cases of convertible to linear. So, in most of the engineering and science questions or in future, you will be experiencing this type of linear equations. Mostly you will be experiencing this type, and this is only one special case that we have handled here. Okay, okay, come on, make a note of this. This page also. Okay. So, now let us look at some of the examples. Okay. So, with this we finish the theory for today. Now, let us look at some problem solving techniques. So, there is one example here. So, what is our standard approach? Convert this into the standard form. So, y dash plus 2x by x square minus 1 into y is equal to 1 by x square minus 1 whole square. I have basically divided with x square minus 1. Now, I need to generate the integrating factor. So, IF is equal to e raised to integral of 2x by x square minus 1 dx. Now, if you look at that, the power is the numerator is the derivative of the denominator. So, you know such integrals. Okay, let me write some rough work here. So, integral of f dash by f dx is going to be ln of mod f. You know this idea. Okay. So basically we can write this as e raised to ln of x square minus 1, but e raised to ln of something is same thing. Okay. So we got the integrating factor. What is the next step? We don't want to multiply and complicate the algebra. We directly write integrating factor into dependent variable y is equal to integral of integrating factor into RHS dx. Okay. Now see if there are any terms that could get cancelled. This is getting cancelled and we are getting integral of dx by x square minus 1. We can integrate this by partial fractions. So 1 by x square minus 1 will be having basically two factors, x minus 1, x plus 1. Now we want to generate factors, so we can just go for simple manipulation. Now when I put ones here and add them, x will not get cancelled. To cancel x, we have to subtract. Okay. So but when we subtract, we will get 2 in the numerator. So to balance it, we need 1 by 2. So we can write this as 1 by 2 into integral of 1 by x minus 1 minus 1 by x plus 1 into dx. Now this will come out to be 1 by 2 into ln of x minus 1, and here there is also minus log x plus 1. So we can write this as mod of x minus 1 by x plus 1. Okay. So now further one integrating constant should be added. So y can be directly written here, or you can also just leave it like this. Okay, depending on the situation. So this way we can complete the problem here. Okay. So this is very basic idea of solving the question. But there is also another idea that if you look at these two terms directly, they look like this: x square minus 1 into d by dx of y, which is the y dash, plus d by dx of x square minus 1 into y. Aren't these the terms? Because derivative of x square minus 1 is nothing but 2x. So we basically got the product rule here. So x square minus 1 into y whole dash is going to be this term. So if you can directly notice such exact differentials, you can also use them directly without going for the long analysis. Okay. But you will not get rid of this RHS step. Of course, you need to integrate in the same manner. Okay. So this way we can solve this. Come on, make a note of this. Okay. Now let us solve another question. So here it's a slightly different question where our independent variable is not x but y. So here y should be taken as the input and x should be taken as the output. Why? Because you can observe here also, in general our differential equation should be of this form. So this means there should be one term with y dash, one term with y, and other should be only in terms of x. But here there are more terms in terms of y than x. There is only one term of x. There is only one x available, which means here our primary variable is going to be x. Okay. So you have to assume that y is the input and x is the output and solve it. So that means basically we are interested in converting this equation in terms of these x dash and x. Okay. So let me take x dash as the dx by dy for the problem solving purpose of this question only. Okay. So I am taking x dash as dx by dy. It does not matter because it's your own theory. You can also design your own variables and notation. Okay. So now if I divide this with dy by dx, here dx by dy term will come plus x minus e raised to tan inverse of y. This is equal to 0. So now if you notice, we have terms like 1 by y square into x dash plus x is equal to e raised to tan inverse y. See, it's in the standard form. It could be converted into standard form. So, we will write this as x dash plus 1 by 1 plus y square into x equal to e raised to tan inverse y divided by 1 plus y square. Okay. Now, this is in the standard form. Our input is y, output is x. So, what is the next step? Go for the integrating factor. So, integrating factor is going to be e raised to integral of 1 by 1 plus y square into dy. Now, integral of 1 by 1 plus y square is nothing but tan inverse of y. So, e raised to tan inverse of y is our integrating factor. So, what is our next step? Directly integrating factor into dependent variable x. This must be equal to integral of integrating factor e power tan inverse y into RHS e power tan inverse y divided by 1 plus y square. Now, what is the variable with respect to what you are integrating? It is y. So, we put dy here. Okay. Now, further process is about integrating this. Okay. So, let us integrate this RHS part. Okay. So, this is our RHS. Okay. Now, if you notice, derivative of tan inverse is basically 1 by 1 plus y square. So, that means if I put tan inverse of y as t, then dt is equal to 1 by 1 plus y square into dy. So, that means this integral will get converted into e raised to 2t into dt. So, you know how to integrate this, it is very silly integral. So, e power 2t by 2 plus c, this is our integral. What is our LHS? LHS is e power t into x and RHS is e power 2t divided by 2 plus c. So, we can write x as e raised to t by 2 plus c into e raised to minus t, or we can write also using the tan inverse as e raised to tan inverse of y into 1 by 2 plus c into e raised to minus tan inverse of y. Okay. So, this way we can complete the solution. Now, even after getting the solution, if you look at this, you cannot write y in terms of x, but you can write x in terms of y. Okay. So, here the solution also happens to be like this. So, we may encounter these kind of situations in future also. Okay. So, what exactly is the situation? Our primary variable is not actually y here, it is x. So, you have to assume that x is the output and deal it like that. Okay. So, this is what I have discussed when I was discussing theory also, that sometimes the equation may be little bit different, somewhat different from the original standard equations that we learn, but spontaneously you have to react and you have to hit the right idea. Okay. So, with this we will close today's lecture. I hope you enjoyed the lecture. We will continue the next lecture with the problem solving because we have few more problems that are left out, and then we will go to the concept of the next lecture. Okay. So, I hope you guys are taking care of your health also. So, stay home, stay healthy, eat well, exercise well, stay healthy and study well. Okay. We will meet again in the next lecture with new ideas and new problem solving skills. Until then, have a great learning day. Learning shall never stop.